All right. Let's see. Does the video work? Ah, perfect. All right. So now we're going to be doing the review. We're continuing off number 21. So number 21 talks about how to solve for x based off of exponential functions. So remember, there's three steps: clutter, inverse property, and SADMAP. So when I talk about the clutter, it's pretty much talking about anything that's not getting powered to. So this right here, this plus 1 is not getting powered, so I subtract 1 to get rid of it. It'll be 4x to the power 3 over 4 is equal to 8. Good. And now we're ready to do the algebra 2 concept of this question. So the inverse property is regards to the 3 over 4. So the opposite of 3 over 4, or like the inverse property of taking the power of 3 over 4, is going to be 4x to the power 3 over 4, is going to be 4 to the power 3, like this, is equal to 8 to the power of 4 over 3. You have to, what you create on the left side, you have to also create on the right side. So, in the end, I'll move this right here. So it's going to be 4x is equal to 8 to the power 4 over 3. Good. And now, SADMAP, pretty easy. You can do this using Desmos, which is, I believe, 16, is equal to 4x. And then x is equal to 4. Just because you divide, if you didn't know. Oh. If you divide by 4, then that equals this. Pretty easy. Good. So you try number 22 by yourself. Pretty easy. Same steps as you can see right here. Let's continue to number 23. So same concept. We have to first do our clutter. So number 23, we're just going to divide by 2 first because the 2 is not getting powered. So x to the power 2 over 3 plus 34 is equal to 25. And the next thing is that, well, the 2 over 3 right here is not on top of the 34 as well. So I can move this 34 as well. So it should be x to the power 2 over 3 is equal to negative 9. Like this. There we go. So when you have this negative 9 right here, and we try to type this into I got to do the inverse property. Sorry. So the inverse property is going to be x to the power 2 over 3 to the power of 3 over 2 is equal to negative 9 to the power 3 over 2. But what happens is that, well, the left side turns into x. That's the reason why we do the inverse property. But for the right side right here, if I type this into Desmos, I get undefined, which is perfectly fine. And that's because negative 9 is negative. So in the end, no real solutions, or NA. That's okay. So if I try to type this into Desmos like this, negative 9 to the power of 2 over 3, 3 over 2. What happened? What is this? Oh, maybe I messed up. But I don't want to record this again. Here we go. Negative 9 to the power of 3 over 2 is undefined. Perfect. You do need to put this in parentheses. Good. 25 is pretty simple. So 25 is talking about exponential rules, where if you have like 5 squared times 3 times 5 to the third power, you can actually add your exponents together. So it should be 5, 2 plus 3. So in the end, remember we have two categories. We have numbers and we have variables. So 3 times 2 is 6, which I got from here. And x squared times x, this is the same as x squared plus 1 because there's a power of 1 right here. That equals x to the power of 3. So I just put these together, 6x to the power of 3. Very easy. 26 is very similar, and also 27 is very similar as well. So you can pause here if you need to copy this, but my goal is to not make this video too long. So number 27 is the same idea where you take the numbers and the variables, where it's still 3 times 2 is 6, which I got from the question right here. And x to the power 1/5 times x to the power 3/5 is the same as x to the power of 1/5 plus 3/5, which is x to the power of 4/5. So put these two together, 6x to the power of 4/5. And 2 more questions, I guess? Yes? So if you want to add or subtract, your radicals must be the same. But when you multiply and divide, only your index need to be the same. So here, I can change this 4 to turn into a 12 by multiplying by 3. So this is going to be 16 to the power 9 over 12 divided by 16 to the power of 3 over 12. So if I take the same thing, 5 to the power 3 times 5, or divided by 5 to the power 2, this is 5 to the power 3 minus 2, which is equal to, well, 5 to the power 1. So the reason why we have to have our index the same is because when I subtract fractions, they have to have the same denominator. So this is going to be 16 to the power 9 over 12 subtracted by 3 over 12, which is 16 to the power of, 9 minus 3 is 6. And I know that this 6 over 12 is really 16 to the power 1/2. And I know that 16 to the power 1/2, it looks like this in radical form. And if I type this into Desmos, it's 4. So very easy. You can pause here. You can take a look. You can also look at my link of notes for 6th period. Last one, 31. So 31, a power of a power. So if I have 5 squared to the power of 3, this is the same as 5 squared times 3, which is 5 to the power of 6. So here, the first rule is that you have to distribute the exponent. So it's going to be 16 to the power of 3 over 2 times x to the power of 6 to the power of 3 over 2. So this one, I can use Desmos, and the reason why I can is because no variables. And this one right here, I can actually use, my rule that I just learned, which is x to the power of 6 times 3 over 2, which is x to the power of 18 over 2, which is the same as x to the power of 9. You can pause if you need more time. I believe this is 64, and with the x, this becomes 64x to the power of 9. But yeah, that concludes the rest of the review. Our test is next class period, which is on Thursday and Wednesday for my A days, Thursday for my B days. And if you have any questions, please send me an email. I'll get to you as soon as I can. But other than that, I'll see you next time.